Hi guys, I'm Hargobind Khurana and today on 26th January, let's make a firm resolve to become more disciplined and to encourage more discipline, especially on roads and also by creating new technologies which encourage discipline. So today I have made a project, the automatic traffic spikes, which are basically spikes that come up whenever there's a red light. So if someone's trying to jump the red light, the spikes are going to come up, and if he tries to jump the red light, then his tires are going to get deflated. So now I'm going to give you guys a quick demo on how this thing works. So see, now it's a green light, so there are no spikes, and it's a red light, so you can see the spikes. Green light, no spikes. Red light, spikes. The thing goes down and it goes up. So let's try it out with the cars. Green light, car goes on, can go cross through. Red light, can't cross through. Now this particular one is a low-lying car, so let's try it out with the regular car too. Can go on. Red light, tires will get deflated if it tries to go. The components which I have used are also very basic. So it's firstly you need some sort of project stand sort of thing, like this project maker board. So you can basically put all the things on the board. You've got an Arduino, a servo shield, one servo, and two LEDs, one red and one green, and of course some battery or other power source to supply power to the Arduino. The road is made from packaging material which you can usually get from Amazon parcels, on which I've pasted black paper and this white strips of paper to create the road, and nailed, basically screwed it onto the board with the spacer in between. Also, the spikes are actually male to male headers, which are something like, if you got female points like the ones on the Arduino, you can place that thing to convert all of those into male points. And the way I've attached them to the servo is also pretty simple. I have simply basically I've put on a servo head and I've hot glued the spikes onto the servo head. Now I'll be showing you the connections very quickly. They're very easy connections, nothing very complicated. So as you can see, this yellow jumper is connected to pin number 9 on the Arduino, and this goes to the positive terminal of the green LED, and the blue jumper wire is connected to pin number 8 on the Arduino board, and that goes to the positive terminal on the red LED. Both the ground terminals on the LEDs are connected to the ground pins on the Arduino board. The servo has 3 wires. So one's the brown one, which is the ground, the red one, which is the 5 volts one, and the yellow one is the signal wire. So we're giving those here. So the ground is given the ground, the 5 volts is given the positive, and the signal wire is connected to pin number 2, as you guys can see here, pin number 2. And we can control the movement of the servo by pin number 2. So I'll be showing you the code now. Okay guys, so here's the code. In the first line, we've included a library known as the VariSpeed servo. You can download this library from the link which I've sent in the description below. Then we are basically declaring our servo called the servo 1, and we are specifying the type as VariSpeed servo, VariSpeed servo, which is basically from the library. Then we are defining the red LED's positive terminal and also the green LED's positive terminal, which is 8 and 9 respectively. In the void setup, which is the code which will run only once, the pin mode of the red LED, we've set the pin mode of the red LED as output, and the pin mode of the green LED as also as output, since we are sending voltages to these pins and not receiving any voltages. And I've also written servo1.attached to. This basically tells the Arduino that the signal wire of the servo is attached to pin number 2. So we'll be communicating via pin number 2. In the void loop, firstly, I've told the Arduino to turn the green LED on by giving it a digital write green high statement. Then we tell the servo 1 to switch to turn over to 170 degrees at 100% speed. So this 100 signifies 100% speed. If I would have written 50, it would have gone at half the speed, 50% speed. And then, so this basically what these two lines do, firstly they turn the green LED on, so the green light is on, and they also make the spikes go just below the road level, so the spikes are now below the road, so people can pass through right now. And there's a delay of 5 seconds, so it will stay this way for 5 seconds. After that, it will turn the green LED off, so digital write green low, a low voltage, that's 0 volts to green LED. Then without any delay, it will turn the red LED on, which will be almost simultaneously since microcontrollers work at a very fast speed. And it will set the servo to 180 degrees, and what that does is that it causes the spikes to appear just above the ground and serve their purpose, so that no one will cross over, as the tires will get deflated. And after that, again there's a delay of 5 seconds, so it will remain above the ground for 5 seconds, and it will also keep the red LED on for 5 seconds. Then it will switch the red LED off, and it will be looped all over. So red LED will be switched off, green will be switched high, switched on, and so on. Again, the entire thing will be looped. So it's a pretty simple code, guys. It's very easy to learn too, and I don't even need to scroll down to show you the entire code. It's just this much of code. This is the total code. Thanks for watching.